Welcome to my YouTube channel Genius Maths and Physics. In this video, we will discuss some questions carrying 3 marks, which is important from the exam point of view. Question is, a galvanometer of resistance 100 ohm gives full scale deflection for a current of 10 milliampere. In this line, you are getting galvanometer resistance as G, which is 100 ohm. At first, we will take it in the form of 10 square. Then gives the full scale deflection for a current of 10 mu ampere. It is given Ig, which is 10 mu ampere. That is 10 into 10 to the power minus 6 ampere is equal to 10 to the power minus 5 ampere. Find the resistance needed to convert an emitter of range 1 ampere. Here another data is given, which is the emitter to measure the current of 1 ampere, I equal to 1 ampere. So what is the resistance needed? That is S. It is called shunt, which is to be calculated by the formula S is equal to Gig by I minus Ig. Here you replace the values of G as 10 square into Ig as 10 to the power minus 5 divided by I as the formula, I has taken 1 ampere minus 10 to the power minus 5. So it can be calculated as 10 to the power minus 3. 1 ampere minus 10 to the power minus 5. It can be calculated as 1 ampere is 10 to the power 5 into 10 to the power minus 5 minus 10 to the power minus 5. So answer is 10 to the power minus 3 divided by 10 to the power minus 5 into 10 to the power 5 minus 1. You have to calculate this one, do yourself. Show that nuclear density of nucleus is independent of its mass number. Here the question is nuclear density. So density is equal to, it is nuclear density. Density is equal to mass of nucleus, or you can say the mass of nucleus by volume of nucleus. What is the mass of nucleus? Nucleus contains proton as well as neutron. The number of protons in a nucleus is taken to be Z, which is atomic number, Z into mass of proton. Similarly, there are A minus Z number of neutrons will be there, which is mass Mn, mass of neutron, 1 neutron is taken to be Mn. That is volume of the nucleus. Nucleus is spherical in shape, that's why its volume is 4 by 3 pi r cube, where r is the radius of the nucleus. We know that radius of the nucleus r equal to r0 into a to the power 1 by 3. Therefore, our answer becomes nuclear density as it is Zmp plus a minus z into mn by 4 by 3 pi r cube, means it is r0 q into a. R0 q into a. So we can calculate this one as Zmp plus a into mn minus z into mn by 4 by 3 pi r0 q into a. Generally, the order of mass of nucleus and mass of proton and mass of neutron is equivalent. So you can cancel these two. So you are getting a into mn divided by 4 by 3 pi r0 q into a cancels. So this expression is not containing a. Therefore, you can say the nuclear density is independent to the mass number. It is not depending on.
Next question. Two capacitors of capacity 200 μF and 400 μF are respectively raised to a potentials of 100 volt and 200 volt respectively. Calculate the common potential when they are connected in parallel. In this question, we are provided the two capacities. First capacitor's capacity 200 μF. And second capacity C2H 400 μF. Similarly, given V1 is equal to 100 volt and V2 is 200 volt. Our question is to calculate the common potential. Common potential is equal to, there is a formula, common potential as V equal to C1 V1 plus C2 V2 by C1 plus C2. C1 V1 that is 200 mu f into 100 volt plus 400 mu f into 200 volt divided by C1 plus C2. It is 200 plus 400, it is 600 mu f. Take mu f and V common, so that you are getting 200 into 100, 200 into 100 plus 400 into 200 divided by 600 mu f. Mu f cancels. 200 into 100 plus 400 into 200. It is 200, 100 plus 400, 200, 800, 100 by 600. We can calculate this one as 200 plus 800,000, 100 by 600, it is 0. So 1000 by 6, answer is 500 by 3 approximately. 1500 by 3. It is 66.667. Question number 4. A ray of light passes through a glass prism of angle 60 degree, undergoes a minimum deviation of 30 degree. Calculate the critical angle of the glass. Very simple question. You have to apply the formula here. Mu is equal to sine of a plus dm by 2 by sine a by 2. This is a common question of prism. So, this is the formula which is to be calculated for mu. If mu is known, then you can calculate the critical angle by using the formula mu equal to 1 by sine c. So, sine c is equal to 1 by mu. So, c equal to, you are getting sine inverse 1 by mu. This is the fundamental. So now I am going to calculate it. A equal to 60 degree. Minimum deviation, that is dm, which is given 30 degree. Then formula is mu is equal to, you are getting sine of a plus dm by 2. 60 plus 30, 90 by 2, it is 45 divided by sine 60 by 2, that is sine 30. So 1 by root 2 by 30, it is 2 root 2 root 2. So mu equal to 1 by sine c. So sine c is equal to 1 upon mu. So 1 upon root 2 is equal to sine 45 degree, therefore C is equal to 45 degree. Next question. The magnifying power of an astronomical telescope is 10 in normal adjustment and corresponding tube length is 10 cm. Calculate the focal length of objective and eyepiece. In this question, it is given magnifying power of the astronomical telescope. In normal adjustment, the magnification M is equal to F0 by Fe. So this one is given 10. So you can get F0 or F0 is equal to 10 Fe. Focal length of objective is equal to 10 into focal length of eyepiece. But corresponding tube length is 110 cm. So it is given F0 plus Fe, which is equal to 110. So you have taken F0 is 10 Fe, 10 Fe plus Fe, this 11 Fe is equal to 110. Therefore, Fe is equal to 110 by 11 is 10. Since Fo plus Fe is equal to getting 110, Fe is 10, so Fo is equal to 110 minus Fe is equal to 110 minus 10 is equal to 100 centimeter. It is centimeter, I think, centimeter, yes. Objective and eyepiece, the focal length of objective is 100 centimeter and for eyepiece it is.
A metallic wire of length 1 meter is traced to double its length. Calculate the ratio of initial and final resistance. Here question is length is 1 meter, so you can take the first length as 1 meter and it is double to its length, so it is taken to be L2 as 2 meter. Then calculate the ratio of initial and final resistance. Here a fundamental is here. So let us take A1 is A, then A2 becomes A by 2. Because of the length is doubled, they were keeping density constant, area would be halved. This is the fundamental here. So now you can calculate R1 by R2. R1 is rho L1 by A1 by rho L2 by A2. So rho cancels. There is L1 by A1, 1 meter divided by 1 by A divided by 2 by A by 2. So you can write it as ratio as R1 is to R2, which can be calculated as 1 by A by 4 by A So it is your 1 by 4. So R2 is to initial final resistance, R1 is to R2 is equal to 1 is to 4. Question number 7. Next question. 125 tiny identical spherical droplets coalesce to form a big drop. If the potential of small drop is 5 mu volt, then calculate the potential of the big drop. In this question, there are tiny identical spherical droplet. Let radius of the small drop is equal to small r. Then volume of each drop is 4 by 3 pi r cube. Since 125 tiny spherical droplet, therefore net volume of 125 droplets is equal to 125 into 4 by 3 pi r cube. If radius of the bigger drop after coalescing is equal to r, then volume of the drop is equal to 4 by 3 pi r cube. According to question, 125 tiny droplets coalesce to form a big drop. So 125 into 4 by 3 pi r cube is equal to, r cube is equal to 4 by 3 pi into capital R cube. 4 by 3 pi, 4 by 3 pi. So r is equal to q root of 125 r cube. So it is answer 5r. Now the question is calculate the potential of the big drop. The potential of small drop a big drop as per the formula B equal to 1 by 4 pi epsilon 0 Q by R. 1 by 4 pi epsilon 0 Q by small r by 1 by 4 pi epsilon 0 Q by capital R. So our answer becomes cancels, so it is R upon R. Our question is R upon R means it is R upon 5R upon R cancels only 5. The potential of small drop, that is 5 mu volt, divided by potential of the big drop, that is to be X, is equal to 5. So X is equal to 1 mu volt only. The potential of bigger drop is 1 mu volt. Question number 8. In a common emitter configuration, the base current is given. Calculate the emitter current if beta is equal to 100. Formula: beta is equal to IC by IB. Here given IC by IB. Here given IB is equal to 100 mu ampere. So IC is equal to beta into IB. Beta is given 100 and it is 100 mu ampere. So answer is IC is equal to 10 square into 10 to the power of minus 4. It is 10 to the power minus 2 ampere. Now what is the value of IE? IE is equal to IB plus IC. We are provided with IB as 100 mu ampere. 100 mu ampere 10 to the minus 6 ampere plus 10 to the power minus 2 ampere. We can calculate as 10 square into 10 to the minus 6 to 10 to the minus 4 plus 10 to the power minus 2 ampere. 10 to the power minus 4 plus 10 to the minus 2, its calculation is 0.0101 ampere. Answer. Next question, question number 9. Two resistors 4 ohm and 5 ohm are connected in parallel so that a net current 3 ampere flows in the circuit. Then calculate the current which is flowing through 4 ohm as well as 5 ohm resistance. In this question, what you have to do, the current in the 4 ohm resistor, current in, we take the fundamental first, current in a resistance is equal to main current into resistance of other branch divided by total resistance. Here main current is 3 ampere into, if I want to find out the current in the 4 ohm resistor, then I have to take the resistance of other branch, it is 5 ohm. So 3 into 5 ohm divided by 4 plus 5, it is 9. So answer is 5 by 3 ampere, the current in 4 ohm resistance. Similarly, current in 5 ohm resistance would be, using this fundamental, we can write the main current is 3 ampere into resistance of other branch, it is resistance of other branch is your resistance of other branch taken as to be 4 ohm divided by 9 ohm. 3 and 9, it is 3. So answer is 4 by 3 ampere. This can also be calculated as I is equal to I1 plus I2, that is current through 4 ohm resistor plus current through 5 ohm resistor. If we got the current in 4 ohm resistor as 5 by 3 ampere, then current in the 4 ohm resistor is 5 by 3 ampere, then current in 5 ohm resistor is equal to I minus I4, it is 3 minus again 5 by 3, we can get the answer is 4 by 3 ampere. Calculate the half-life period of a radioactive substance if its activity drops to 1/16th of its initial value in 30 years. Here the fundamental to be used, formula to be used is half-life period is equal to time of disintegration divided by number of half-lives. In this question, we are provided with initial value is n0 and the activity reduces to 1/16th. Therefore, n is equal to 1/16th of initial value n0. N is equal to 1 by 16 n0, therefore 1 by 16 n0 equal to n, or n equal to, we are getting n0 upon 2 to the n. H, n equal to 1 by 16 n0, so we replace this value, so we will get n is equal to 4. As the number of half-lives is equal to, we are getting 4, the half-life period is equal to time of disintegration divided by number of half-lives, that is 30 by 4 is equal to 7.5 years.